Here we have a SAT math question. Okay, let's go the question. Which expression is equivalent to a to the power 11 over 12 where a is greater than 0? Okay, here so we have the power of, the exponent of a over here is a fraction. But when I look at the options over here, so here we have radical, there is 12th root in option A. In option B we have 1 on 44th root, and in option C, in option D, in all the options we have radical. So we have to convert this exponent to radical. So that's a work over here. Okay, before we are trying to solve this problem, let's consider the base a with the exponent 1 over 2. So here the base is a and the exponent is 1 over 2. So whenever we have an exponent in this form, that is 1 over 2 means like the numerator is 1 and the denominator is 2. This exponent can be written as a radical. So we have radical a. And what is the index of this radical? Index of the radical is the value I have in the denominator, that is 2. So 2 means we don't have to mention over here, it's a square root of a. And also please make sure the numerator has to be 1 always. Okay, so what if the exponent of a is 1 over 3? So we have to write radical, and inside the radical we have to write this base a, and the index of this radical must be the denominator. So that is 3. So this is cube root of a. And what if the exponent is 1 over 4 to the base a? Again, we have to write radical sign, and inside the radical we have to write the base a, and the index of this radical is the denominator, that is here the denominator is 4, so it has to be 4th root. So in all the 3 cases, the numerator is 1. So always we have to make sure the numerator has to be 1 so that we can convert this fractional exponent as radical. Okay, now let's apply the stuff what we have learned here in our problem in this a to the power 11 over 12. Okay, so as I said, the numerator has to be 1, but here the numerator is not 1, it's 11. So our first work is what we need to do is we have to convert this numerator 11 to 1. So for that, I'm writing this fraction 11 over 12 as 11 times 1 over 12 because I want to get the numerator as 1. Okay, now let's consider the power of a power rule in exponent. What is the power of a power rule in exponent? Okay, let's consider a and let's consider m, the exponent for a, and for the complete stuff let's consider another exponent n. Okay, so here the base is a, so the base a is having exponent m, and the complete stuff a to the mth power as exponent n. So whenever we have two exponents like this, what we can do is we can multiply the two exponents, that is m times n. So this is the power of a power rule in exponent. And also we can use this power of a power rule of exponent in reverse order. That is, whenever two values are multiplied at the exponent, what we can do is we can take one of the values as exponent for this base a, then we'll be getting a to the mth power. And the second value should be taken as exponent for the complete stuff. So I'm going to use the power of a power rule of exponent in reverse order. That is, here we have two values are multiplied. So that is 11 and 1 over 12 are multiplied. So what we can do is we can take one of the values. The 11 can be taken as exponent for a. Then we get a to the power 11. And for this complete stuff, we have to take this 1 over 12 as exponent. Okay, now we have a fraction 1 over 12 as exponent for this stuff. Since this is a fraction and also this fraction contains numerator 1, so this fraction can be converted to radical. So when I convert this 1 over 12 as radical, I'll be getting radical, and inside the radical we have to write this stuff, that is a to the power 11. So what is the index of this radical? So that's a denominator, so that is 12. So it can be written as 12th root of a to the power 11. So when I look at the given options over here, in option A, I'm getting 12th root. That is the index of the radical is 12. But inside the radical, I have a to the power 1 and 32. But in my work, I'm getting a to the power 11. So when I'm trying to write this fractional exponent as radical, I'm getting 12th root of a to the power 11. But here I'm getting 12th root of a to the power 1 and 32. So option A cannot be correct. So what do we have to do? Okay, now let's check the other options. In option B, we have the index of the radical 1 on 44. So actually 1 on 44 is a multiple of the denominator over here because 12 times 12 is 1 on 44. But when I look at the index of the radicals in option C and D, 1 and 21, 1 and 21 is not a multiple of this denominator 12, and 11 is not a multiple of this denominator 12. So since 1 on 44 is a multiple of this denominator 12, so we can try to change this 12, the denominator 12 to 1 on 44. How? So for that, we have to multiply both numerator and denominator by 12. Let's do that. A to the power 11. So I multiply the numerator and denominator by 12. Okay, when I do so, I'm getting a to the power 11 whole to the power. So here I can write the 12 over here as it is times 1 over, when I multiply the two 12s in denominator, 12 times 12 is 144. Okay, here two values are multiplied. So as we have seen over here, whenever two values are multiplied at the exponent, one of the values can be taken as exponent for this base, and the other exponent can be taken as exponent for the whole stuff. So now let's take this 12 as exponent for this stuff. Then I'm getting a to the power 11 to the power 12. And for this complete stuff, we have to take the second value, 1 over 144 as exponent. Okay, here we have the base a, the exponent 11. And for this complete stuff, we have exponent 12. So this is similar to a to the power m or to the power n. So what do we do over here? We multiply the two exponents m and n. The same thing, we have to multiply these two exponents 11 and 12. So then a to the power 11 times 12 whole to the power 1 over 144. Okay, now a to the power, when I multiply 11 and 12, I'm getting 132 whole to the power 1 over 144. So here the exponent is a fraction with 1 as a numerator. So what do we have to do? We can write this exponent as radical. So we get a radical a to the power 132. So what is the index of the radical? So the denominator over here should be taken as the index of the radical. So 144th root of a to the power 132. So I find this one in option B. So the correct answer choice for this question is option B.